Hi friends, welcome to the Unit 3 Day 1 notes. Here in example 4, we're going to write each equation in vertex form and then graph. To write it in vertex form, what essentially we're doing is we're completing the square. I talked about this earlier, completing the square. So let's talk about how we do that. So we're going to move the constant term to the other side. So here I'm going to have 2. For this specific part, note that it's y. We're finding this with y, the y values when we complete the square. So we're going to take out the y part because we're completing the square with the other values here. So here we have 2 equals, negative 2, minus 2 on both sides. Let me show all the steps. That way I don't make a mistake like that. Minus 2 on both sides. So I have negative 2 equals 3x squared minus 6x. Factor out the a value. So by factoring out the a value, we're going to factor out this a value from both of these. So that gives me 3 times x squared minus 2x. And then what we're going to do is we're going to be adding a line. So plus blank here. And then we're also adding a line to this side here. So we have blank. And then it's going to be plus negative 2. What I usually end up doing to help me kind of remember is when I write that negative 2 first, what I'll actually do is I'll write negative 2 and then I'll put in the blank right there so that I remember that I have that. If you see on this side, we're multiplying whatever's in the blank here by 3. So we're going to also need to multiply whatever's in the blank here by 3 as well. So it's going to be 3 times whatever value we have there. We need to take half of the linear coefficient and then square it. This result goes in the line. The linear coefficient, this is your b value from your kind of your quadratic side. So if I take half of negative 2, so half of negative 2 and then square it. This should look familiar. This is what we normally do when we complete the square. Negative 2 divided by 2 is negative 1. Negative 1 squared is 1. So we're going to put a 1 here, and then 3 times 1 is over here. Now remember, it's 3 times 1, so when I write my next step, I'm going to show that. It says factor the side with the trinomial. So we're going to factor this side, and then we're also going to combine this over here. So I have negative 2 plus 3 times 1, so that's 3. Again, that's because 3 times 1, because of this 3 over here, equals 3, and then I'm factoring this side. This side's going to be x minus 1 quantity squared. I need to simplify the negative 2 plus 3. Negative 2 plus 3 is 1, so I have 1 equals 3 times x minus 1 quantity squared. Subtract 1 from both sides. I end up with y equals, because we're going to graph it, y equals 3 times x minus 1 quantity squared minus 1. So again, following through now, we can graph it just like we did with the others. So I have a vertex at 1, negative 1. Excuse me. To find our y-intercept, we plug in 0 for x. If I plug in 0 for x, I can actually go back here and see that it's 0, 2. Graphing with the blue pin. I was graphing with my red pin from earlier. 0, 2. Which should follow our vertical stretch idea that we have, because our a value, notice your a value is the same in both. Your a value is 3, both forms. This is the same. These are the same equations. They're just represented in different forms. So this one, we were just able to quickly find our vertex. The a value, it's going up by 3, factor of 3 each time. So my next one that I would go up would be by 12, very large amount. So this vertically stretches rather quickly. So the only points that I can say with absolute certain are these 3. Could find the x-intercepts and go from there. I'm just going to leave it as this. This next one's not as pretty, however, it is doable. So we're going to subtract 3 from both sides. I'm going to go ahead and leave the y over here to show you how this looks like with this. So I have y minus 3 plus blank. So this is going to be y minus 3 plus blank equals 2x squared minus 5x. Remember, we're going to factor out this 2 to get our other blank. And that also tells us what number we need to multiply by here. So we have y minus 3 plus, and it's going to be 2 times whatever we're going to put in this blank, 2 times, equals 2, and then parentheses x squared. So in this case, this 5 is not an even number. So when we factor it out, we have 5 over 2x plus blank. Now, a lot of students get confused on what to do with that, but remember, we just go through and do the same thing. So we're going to take half of 5 halves. So this is the half of 5 halves. Didn't make my parentheses big enough. And then square. Excuse me. Half of 5 halves. So remember, when you have... I'm going to go through and show this, just because sometimes there's some confusion. Remember, this is 2 over 1, so we're multiplying by the reciprocal. So we have that, multiplying it times 1/2. So this ends up being negative 5/4 quantity squared. When you square both, you square the numerator and the denominator. So we're going to end up with 25 over 16. The parentheses are not necessary. That's the value we're adding to both sides, 25 over 16, and then 2 times 25 over 16. So for this part, when we go through, we're going to have, simplifying that, we've got, let's see, 2 times 25 over 16, let's see, that's going to simplify to 25 over 8. So I have y minus 3 plus 25/8 equals 2 times x. Then if I factor this, this is going to be x minus 5/4 squared. I'm going to go ahead and turn this into a decimal. 5/4 is negative 1.25 quantity squared. I'm going to go ahead and convert this to a decimal too. I don't know what that is off the top of my head, and I just moved and put my calculator away. There we go. So 25 divided by 8 gives me 3.125. So that's going to be y plus 0.125 is equal to 2 times x minus 1.25 quantity squared. Add 1.25 to both sides, or sorry, subtract 1.25 from both sides. You get y equals 2. 2 times x minus 1.25 quantity squared minus 0.125. So this one's difficult to graph precisely, and I would not ask you to graph this on a quiz or a test where you've got these values that are difficult to find on the graph, just because of the nature of it. I do want to point out, converting it to this form did allow us to find our vertex rather easily, but it's almost beneficial just to keep it into this form as we're solving, or sorry, as we're graphing. So knowing kind of the best path to take is important, which you should have done in Algebra 1. So my y-intercept is going to be here. Let's see, my vertex is going to be at positive 1.25, so a little bit, and then here. And that's going to be my axis of symmetry. So 1 and bit puts us here. So we're going to have something like this. For our quadratic. Other values. Join me in example 5 as we talk about fraternities, throwing people up on blankets. Have a wonderful day.